Hello everyone, I'm Yang. My project is about 2D stack modeling of tensile tests using single, bi-crystal, and polycrystal specimen. Tensile test is a very practical way to measure the mechanical properties of a material because the stress state is quite simple in the sample. To make a static simulation of a tensile test, first we build geometry of a tensile specimen and then mesh it with a 4-node quadrilateral element. The boundary condition in this case will be all the nodes on the left edge is fixed and all the nodes on the right edge is applied by a load of 10 to 6 Newton per meters. So finally, we output those nodes connectivity material properties into my MATLAB solver to solve the problem. So one task of this simulation is to see if I can get different mechanical response when I use different specimen, single crystal, bicrystal, and polycrystal specimen. In general, I use titanium as my material type, but for different grains, they will have different Young's modulus and Poisson's ratios depending on the grain orientations. The left three images are generated from the Mark solver, and the right three images are plotted in the MATLAB. Here are direct solutions from MATLAB. We observe little difference between single crystal and polycrystal displacement fields. For X displacement, we both observe an increasing trend from left to right, and X displacement reaches maximum at the right end. For Y displacement, we both observe a negative shift on the right end. Then I compare my result with results I got from a commercial solver. For X displacement, it's quite the same, but for Y displacement, the result from the solver is quite uniform, but my result has bend in the center. To evaluate yield behavior, von Mises stress criteria is a convenient way. The von Mises stress is calculated from three components of stress. Images shown here are maps of von Mises stress evaluated in the center of each element. In a single crystal test, von Mises stress is pretty uniform in the center region and higher at the round corner. In a bicrystal, the interface between two grains are more likely to yield because the von Mises stress is higher at those points. In the polycrystal, this specific grain may yield first because it has much higher von Mises stress than other grains. This may be caused by the neighboring grain constraint.